going to prove this identity that parentheses 1 minus cosine squared x times secant x equals sine x tangent x. Okay. First thing I'm seeing with this proof is on the left side, if I see a 1 and then a plus or minus, a trig function being squared, like cosine squared, that makes me think these identities over here to the right side. Okay, that's really the first identity. If you subtract cosine squared from both sides, you get that sine squared equals 1 minus cosine squared. So my first step, so I'm going to write that as sine squared. And I'm using shift 6 to get a caret to get the exponent key really fast. You can click over here to use these buttons. That works fine. But shift 6 gets you an exponent really fast. All right, so we used the Pythagorean identity to make that happen. Okay, so I've got a sine, which is what I'm supposed to have on the right side, so that's good. But we're only supposed to have one sine. So let's think about how we can rewrite this. I'm thinking tangent. Keeping in my mind that tangent x is sine x over cosine x. So maybe if we rewrite secant as its if we just rewrite secant x as its reciprocal identity, it's 1. Oh, dang it! It's 1. 1. There we go. 1 over cosine x. Again, that's the reciprocal rule that secant x is 1 over cosine x. Now I could use some algebra to rewrite. Let's take one of the sine x's and put it in that fraction. Right? It's a valid move because if you were to put a 1 underneath sine squared x, you would multiply straight across the top, straight across the denominator. So we can move one of the signs in the sine squared x to the top of that fraction. So this is just algebra. We didn't use any fancy trig rules or anything for this one. And for the final step here, I think we're done. Sine x times sine over cosine, that is the definition of tangent x, and that's what we sought to prove in the end. So, oh, I didn't select a rule. That was, they call this in aleks the quotient identity. Sine x over cosine x, if you say that's tangent x, that's the quotient identity. So the proof's done. Hit check, and then Alex should be like, yippee, good job. Let's see if I can exit this.